In this lesson, you will learn how to work with the vertex form of quadratic functions. The vertex form is y equals a times x minus h quantity squared plus k. When we name the vertex, it will be our h, k values. Being especially careful when you name your h, you're going to write the opposite of what you see, and the k, you write exactly what you see. The axis of symmetry is going to be the same as your x value of the vertex, or the h value. We can still use the a value of our function to determine if we have a max or min. So in vertex form, that a value, if it is positive, it's going to make the graph open up, meaning we have a minimum for our vertex. If our a is negative, our graph is going to open down, meaning we have a maximum for our vertex. So let's look at these examples and name the vertex. This is in vertex form. We have 3 times x minus 2 quantities squared plus 4. We can name our hk in order to find the vertex. So first we want the opposite for the h, so we would write a 2. We see a negative, but you'll write the opposite, a positive 2. For the k, you write exactly what you see, so 4. So when an equation is in vertex form, you can just name the hk, being careful with opposite and exact to name the vertex. For the axis of symmetry, it's going to be the same as the x value of the vertex, so x equals 2. This equation, because our a is a positive, that a value being a positive makes the vertex be a minimum. The graph will open up, so the vertex is the lowest point, meaning a minimum point. Let's look at our next example. We have y equals negative x plus 4 quantity squared minus 5. We'll name the opposite for our h. So we see a positive 4. We're going to write down negative 4. And we'll name our exact for our k. The exact thing you see is what you write down, so negative 5. Our axis of symmetry will be the same as the x value of our vertex, or the h value, so negative 4. And looking back at our a value, we see that it is a negative, so that means we are going to have a maximum for our vertex. Our graph will open down when that a is negative, and the vertex will be the highest point, or a maximum. So let's look at some examples where we can change standard form to vertex form. This is a process called completing the square. So our equation, y equals x squared minus 8x plus 9, that is in standard form. We can complete the square to change it to vertex form. So we first want to rewrite the problem with a plus and a minus a blank. So we have x squared minus 8x plus a blank. Scoot that 9 out of the way, so plus 9 gets scooted over, and then you're minus a blank. The reason we are doing this is first we want to find a number for that blank that makes this a perfect square trinomial. We also are doing a plus and a minus because when I add a number, it's making it different, so I have to subtract that same number to still make it equal. Let's say, for example, if I took your age and added 5 years, you just became 5 years older. I'd have to subtract the same amount, so minus 5, so you're still the same age. So we're going to add and subtract the same number. To find that number, we take half of our b and square it. So take b and divide it by 2, and then square that. So in this problem, our b value is negative 8. Take negative 8, divide it by 2, and then we will square that. I do want you to do this at a step at a time. So -8 divided by 2, show what that equals before you square it. This number will be important to us later in our work. So show this step of taking half of the number, that is -4, and then square that. So -4 squared is 16. Be sure if you're squaring this in a calculator that you put parentheses around the -4. Think about negative times negative is a positive. You should always get a positive when you're squaring a number. So that goes in the plus and the minus blank, whatever you found for the half of b squared. So now the first 3 terms are factorable. You don't have to go through the process of factoring because it is a perfect square trinomial. It works out that this number, half of the b, so that -4 from earlier, is the factor that you will use. So x minus 4, because it was a -4. It will be in one parentheses squared. So the first 3 terms now are a perfect square trinomial, and what we're doing is actually factoring it without all the factor work. We just take the half of the b and put it in the parentheses. The next 2 terms, 9 minus 16, you just combine them. So whatever that equals, 9 take away 16, -7 is what you will have. So that is now in vertex form. We can name our vertex using our h, k. So h, do the opposite. K, do the exact. And our vertex is 4, -7. Our axis of symmetry will be x equals 4, so the same value of the x of the vertex, or even the h value. It is important to learn how to check these in the graphing calculator. So you'll first start with pressing y equals. You'll type the standard form into y1 and the vertex form into y2. So the standard form and vertex form, the equation you originally started with, and then your vertex form equation. If we're saying that those should equal, when you go to table, so second table on your calculator, you should notice in the calculator those y columns, all of the numbers are matching. If these equations equal one another, they look different, they're in different forms, they actually do equal one another, we should see that in the table. Also, look for the vertex. We say our vertex is 4, -7. So notice in our table, we see 4, -7. And we know this is the vertex because the repetition on either side of the vertex, we see the -6, -3, 2, and again, -6, -3, 2. That repetition will make that U shape. Of course, you can press the graph to actually see the key features. We have our vertex at 4, -7. We have our axis of symmetry at 4. We also have a y-intercept. If you go all the way back to the standard form and look at the c value, that was 9. You could see on the graph, or even in the table if you need to, the 9 is the same as your c value from standard form. That will always be your y-intercept. Use the calculator to help you check your work. Not only can you see that the equations are equal and you've completed the square correctly, but you can see that you've identified the vertex correctly. It never fails. It happens all the time that when we name the vertex, we accidentally put -4 for the h when it should be positive because you need to take the opposite. But by checking in the calculator, you can very quickly see that our vertex is 4, -7. Let's look at our next example. Number 2, we have y equals x squared plus 7x minus 5. We're going to need to complete the square. So do your plus a blank, minus a blank. So we have y equals x squared plus 7x plus a blank. Scoot that minus 5 out of the way and then do the minus a blank. To find the answer that goes in the blank, you're going to take half of your b and then square it. So b is 7. 7 divided by 2, do that step first. That is 3.5. And then square that number. Make sure you show this step of the half a b because we're going to need it later. 3.5 squared is 12.25, so that is the number that goes in the plus and minus blank. The first three terms, that is now factorable. It's a good thing we don't have to actually do the factoring because we have a decimal, and that would not be fun. But we know because it is factorable and it's a perfect square trinomial, we can just take this half a b. We have x plus, because that was a positive, x plus 3.5 quantity squared. We now need to combine the last two terms, negative 5 minus 12.25, always being careful to notice your signs. That is a negative 5 minus 12.25. That will give us the negative 17.25. So from standard form to vertex form, you can complete the square, and now we can name our vertex. Our h, we want to name the opposite of what we see, so negative 3.5. For the k, we want to write down exactly what we see, negative 17.25. Our axis of symmetry is going to be negative 3.5, the same as our x value of our vertex. Again, we can check this in the graphing calculator following these steps. Type in your standard form and vertex form. Press second table, and we see that the y columns do match. If they're not matching, go back and check your work from completing the square. We named our vertex as negative 3.5, comma, negative 17.25. But notice that doesn't show up in the table because we don't have the decimals in this table. But we can still feel confident that is our vertex because negative 3.5 would fall between negative 4 and negative 3. And I can see that that's where the vertex would be because we still see that repetition on either side of where that vertex would show. We can look at the graph. The vertex is not showing, but we can see the y-intercept. We could see where the axis of symmetry would be, and we could probably picture where the vertex would fall. Remember, the y-intercept is going to be the same as the c value of the standard form. Let's look at example number 3. Feel free to pause the video and try this one on your own. So we're going to need to do plus a blank minus a blank. In that blank, we want to take half of the b and square it to fill in those numbers. So b is 14. Half of 14 is 7, and 7 squared is 49. That is the number that goes in the plus and minus blank. The first three terms are factorable, so we'll just write x and then whatever the half of the b was, so x plus 7 for this one. The last two terms, you combine them, 57 minus 49. So this is now in vertex form. We can name our vertex. So our h, we want to write down the opposite. K, we want to write down the exact. This will give us an axis of symmetry, also of negative 7. And then notice we can check these in our calculator, typing in our standard form, vertex form, and noticing those tables do match. We even can see that our vertex, negative 7, 8, does show up in our table. We know that that's our vertex because of the repetition on either side. If you were to scroll to positive 7, as you can imagine, that would be a common mistake that students do. They list 7, 8 as their vertex. So if you were to scroll in your table to positive 7, let me tell you, there will not be an 8 sitting there beside. So that should tell you that you've done something wrong. We can see Here in that table, beside the positive 7, it's actually 204. So that would kind of give you an alarm of you've done something wrong. Let's look now at example number 4. We have x squared minus x minus 6. Do your plus a blank, minus a blank. So we have x squared minus x plus blank. Scoot that minus 6 over, and we have our minus blank. Take half of the b and square it. And notice the b here is negative 1. So we're going to take negative 1, divide it by 2. So that is 0.5, or negative 0.5, sorry. And we square that number. So that is what goes in the plus and the minus blank. The first 3 terms are now a perfect square trinomial. We don't actually have to do the factoring because we know our half of our b. So x minus 0.5, and then we combine the terms at the end. Be careful to know that's a negative 6 minus 0.25. So we can name our vertex h and k, being careful with opposite and exact. And then our axis of symmetry will be the 0.5. Again, check your work in the calculator to help you catch any careless errors that you may be making. You can see those key features on the graph with the vertex, axis of symmetry, and the y-intercept, which we said is the same as the c value.